Okay, so we're going to work out most of problem number 1. This can be kind of a tricky problem. You're trying to find the mass of block B. So it says 2 blocks are connected by an inelastic string over a frictionless pulley that does not affect the motion of the blocks. So let's see, here is block A, and here is block B. And of course, you set up a force diagram to begin with for both blocks. And we're looking for the mass of block B. That's our overall goal. What's the mass of block B? Now, there's a couple things that we know. We know that this is an inclined ramp. You have to have this set up correctly first. Here's theta. Theta equals 15 degrees. We know the mass of block A is 3.75 kilograms. And we know that there is a coefficient of friction between the block A and the ramp of 0.45. One more thing that we know that's very important, the acceleration is 1.25 meters per second squared. Okay, so let's set up some force diagrams and see what we can do here. So let's first set up our force diagram for B. That one's pretty simple. Draw some big rows. So for B, we have gravitational force pulling it down and the tensional force pulling it up. And the tensional force should be the greater amount, the gravitational force should be the greater amount because it is accelerating downward. So this is going to be the mass of block B times gravity. So we cannot say that these two are equal. And now let's make a force diagram onto block A. I'm just going to make it directly over block A. You've got your normal force, you've got gravity, you've got kinetic friction, which is operating opposite motion, and you've got this tensional force. Now what we do know is that these two forces, this tensional force, on both parts should be equal. Okay, so tensional force, the normal force from the surface onto block A, the gravitational force onto block A, or on block A, and the frictional force. Okay. Now what we're going to have to do is sum up these two, and again, remember we're solving for block B. So I'm going to go ahead and sum up the forces that are occurring on block A. I'm going to say this is my positive direction is moving downwards, the direction in which block B is traveling. And that should be the force of gravity on block B minus the force of tension is equal to the mass of block B times the overall acceleration of the system. Okay. Now the issue with this is I know acceleration. I know that this is going to be the mass of block B times gravity minus the force of tension is equal to the mass of block B times A. But again, I'm trying to find the mass of block B. I know acceleration, but I don't know force of tension. So I'm left with too many unknowns right now. So let's see what we can get from our other force diagram. I'm going to make this one in, I don't know, aqua. So let's call this my x direction because we do have multiple components here. Draw horrible arrows here. If this is theta, this angle right here is also theta. So the sum of the forces that are acting on block A will be the force of tension. It's completely in, and we'll say this is in the x direction. It's completely in the x direction. But then there are two forces acting opposite that. The kinetic frictional force and the force of gravity on block A, which is trying to pull block A down. Oh, it's trying to bring him down. It's going to equal the mass of block A times its acceleration. Okay, so let's see if we can derive expressions for all these. So we do know that the force of gravity on A would be the mass of A times gravity. So the force of gravity on block A in the x direction should be the sine of theta times mass of A, or times mass of A times 2, excuse me. So let me just write that now. I don't know anything about kinetic yet, but I know this is going to be mass of A times G times sine theta is equal to mass of A times A. And so far I know all this, so this will help me solve something. Let's figure out friction. Now the generalized formula for friction is mu, in this case K, times the normal force. Ruh-roh, we don't know the normal force. But we can think about that these two should be equal. The normal force is always a compensatory force. All it's trying to do is make sure that this thing is not accelerating down into the block itself, or into the sliding ramp, whatever. So this normal force actually should be equal to the mass of block A times G times cosine of theta. And it's cosine because it's adjacent to the angle here. This was mass of A times G. Okay, so let's substitute this in now. If we know normal force, we mu K times that. Okay, so the mass of A, G cosine theta, minus mass A, G sine theta equals mass of A times the acceleration of the system. And this might get us somewhere, because I don't know the force of tension here, and I don't know the force of tension here. But together, the only thing I don't know, if I can cancel out force of tension, then I can find the mass of block B, and I'm good to go. Okay, so what I'm actually going to do is take this equation. I'm going to add them together, because when you add them together, the force of tensions are going to cancel out, and that is just an awesome thing to happen, and we don't have to deal with that anymore. Color should I make this? How about blue? Alright, so when I add these together, force of tension and negative force of tension are going to cancel. So what I'm left with is negative mu K mass of A times G cosine theta, excuse me. Just erase that. Or erase everything, whatever. Anyway, mass of A times G cosine theta minus mass of A G sine theta plus mass of B times G is equal to mass of A times A plus mass of B times A. And again, you don't have to do this. You could solve for force of tension and plug it into the other one. It doesn't really matter. Okay, and remember, I'm trying to find mass of B. And at this point, I know everything else. I know theta, I know mu, I know the mass of A. I just need to find mass of B. So I'm going to bring the mass of B over. And these two expressions both have mass B in them, so that's what I'm trying to solve for. So bring them all over to one side. I have mass of B times G minus mass of B times A, and then everything else moves to the other side, so it's going to be mass of A times A plus mu K mass A G cosine theta plus mass A G sine theta. And you can see you can factor mass of B out. And left with G minus A equals all that. And so your last step, bring it all up in here. Now, notice mass of A is a constant, so you could totally factor that out. And I'm going to do that just so I don't have to write it again. And that leaves you with A plus mu K G cosine theta plus G sine theta all over G minus A. And if we substitute in some values, it's pretty ugly. But we know all of these values. We know the mass of A was, what did it tell us? 3.75 kilograms. The acceleration is 1.25, I believe. Yep, have to keep scrolling up. Mu is 0.45. G, and theta is 15 degrees, so this is cosine 15 degrees plus G sine 15 degrees, all divided by G minus 1.25. And so the approximate mass of B is about 3.528 kilograms. And that's it. Now, this is a completely acceptable answer. And you have so many variables here, but you want to stop and think, what do I know and what don't I know, and what do I want to find? And if there's anything you don't know but you don't want to find, that's what you want to try and eliminate. And this is totally an acceptable answer.